We will be talking in this video about one-sided limits. Okay, all right, let's set up the problem. So given a function f defined on real values with values into the set of real values, real numbers, okay, f of x is equal to 4x minus 3 if x is less than 1 and 2x minus 1 if x is greater than or equal to 1. Okay, so this is the function we are going to be looking at. And the question is, what is limit when x approaches 1 of f of x? Okay, now, in the previous examples, what we did is whenever we were asked to compute a limit, we would replace f of x by the algebraic value of it, hopefully work some algebra on that expression and understand exactly what that limit was. Now, for this particular function f, we have a little problem because as x approaches 1, well, if we look here, okay, we have two ways of defining f. So if x is actually less than 1, we approach, our f of x is this value. While if x is greater than or equal to 1, our f of x is this value. So there's no way you can just replace f of x by one value, one expression, and just work with that. So what we have to do is we have to compute two limits, and these limits are what's called the sided limits. Okay, so basically what we want to do is we want to compute limit when x approaches 1, x is less than 1. So we want to look at these values of x, okay, of f of x. Okay, now some people, instead of writing this, they write limit when x approaches 1 minus of f of x. All right, so this minus here means that we approach 1 from the left-hand side. Okay, now if we do this, there's no problem replacing f of x by 4x minus 3 because this is the value of f of x if x is less than 1. So this is limit when x approaches 1 minus of 4x minus 3. Now we look at this expression. There is absolutely no problem with this expression. We can just plug in x to be 1 in here. So we get 4 times 1 minus 3, which is 1. All right. Now we do exactly the same thing for the case when we approach 1 from the right-hand side. So we are going to say limit when x approaches 1, x is greater than 1 of f of x. Okay, this is equal to, and again, some people will write limit when x approaches 1 plus. Okay, so we are talking about positive numbers, values of x that are greater than 1. So we approach 1 from the right-hand side. Okay, so this is why we put a plus on here. Okay, so limit when x approaches 1 plus of f of x. Well, when we approach 1 but with values greater than 1, this is the definition of our function. So it's going to be limit when x approaches 1 plus of f of x, which is limit when x approaches 1 plus of 2x minus 1. All right? Now again, we look at this expression. There is no problem with this expression. So we just plug in x equals 1. So we get 2 times 1 minus 1, which is 1. Now, so what we figure out is we figure out what happens with the values of f of x when x approaches 1 from left and from right. And we got these two numbers. And luckily, the two numbers are equal to each other. So from these two, we can conclude that limit when x approaches 1 of f of x is equal to 1. Okay, the common value in here. All right. Now, if we actually want a visual representation of this whole scenario, what we can do is we can try to represent our function. All right. So basically, if x is less than 1, so here is 1, that's where we change from one definition to another definition of the function. Okay, so we get 1, 1, so this is 1 point. Okay, now if x is equal to 0, we plug in here, so we get minus 1, 2, 3. This is another point, so we get a half line like so. All right, and then if, for example, if x is 2, we get here 2 times 2, 4 minus 1, 3, so 1, 2, 3. All right, so we get this, another half line here. All right, so as you can see that the two half lines actually connect very nicely around x equals 1, so that's why the limit exists and it's equal to 1. Okay, and actually some people will actually look at, in case you have the graph of a function like this, they'll just look at the graph and say, oh, I see that limit from left is equal to limit from right and it's equal to 1. Okay, okay, that's okay, and you'll see actually in calculus people do this.